Welcome back to the lesson 7 quiz, and we're going to go ahead and get started on number 8. And I went ahead and drew out a quick sketch here, but it's probably got a little bit nicer sketch on the study guide if you want to take a look at that, of course. And it says a 4x10 is connected to two 2x10s by 2 7/8 bolts as shown below. What is the safe load P? Using the table on page 121, all members are Douglas fir, and assume that all spacings, distances, and members are adequate. All right, and you might want to, I guess, there's something that's a little intuitive, and then something that maybe not so intuitive about this table and double shear situations. I guess if I were coming in here and I didn't know anything, what I would do is say, well, okay, we've got two situations here. We've got the 4x10, and we've got the two 2x10s. And just off the top of my head, I'd say, well, the 2x10s will probably be control because, nominally it's 1.5 plus 1.5 is 3 inches. Nominally, this is 3.5 inches, so it's a little bit bigger. And just my quick 2-second thought would say, oh yeah, those will control. So I would say, okay, well, let's just double check this. I'd go over and say, let's do this for the 4x10, then let's do it for the two 2x10s. Sorry about the messy handwriting. I'll fix it. All right, I'm sitting up straight. Two 2x10s. And I'd go through and say, oh, okay. Well, actually, let's do it correctly. And I don't want to confuse you here. This is not what you want to do down here. You don't want to do these two. You do want to do this, and I'll show you why in a second. But let's go ahead and do this. So you'd say, okay, nominally it's 4 inches. Actual, it's 3.5. So you go in the table on page 121, and like they wanted us to, and I obliged. And I go down from 1/7 to 1/8 inch, and I look, and I know it's double shear because two shear planes. And then I say double shear, and that's 3.5. And I look over, and I go down from 7/8 inch, and I see 3580. I know that's in pounds, and I'm going to multiply by 2 because we have 2 bolts. And that's what? 7160 pounds. I hope my math is right. All right, and then you could go down here and say, oh, okay, well, I did that. Now I'm going to do this, and I'm going to say, well, each one's equal. P over this is equal to P. Then you can say, you would go down and say, oh, well, I have 2, and they're what? Actually 1.5 since they're nominally, but they're only in single shear, so you would go over to what? 880, and you multiply it by 4. 830, I guess that is. I can't really read it. And you get 3,320, and that would be B. But that is not correct. And I want to, and once again, that's if I didn't know any better, that's what I would have done. I would have gone in and be like, oh, okay, the answer is B, 3,320. Now, this is once again probably not intuitive for you, but go down to the bottom of that table on page 121 of the study guide and read those little notes. And I guess the notes that I really want you to read are number 2 and number 4. Okay, let's go ahead and read number 4 first. And it says the length specify. Oh, actually, let's read number 2 first. And it says double shear values are for joints consisting of 3 wood members. Okay, that's what we have. In which the side members are 1/2 the thickness of the main member. So this would be the main member. And these would be the side members. Let's change colors. What one haven't we used? Let's go off a little green. Let's lighten it up. There we go. These are side. Ooh, that's popping out like that. All right, so that's your main member right here, and these are your side members. And they are 1/2, you could say, nominally, 1/2 of the main member. I'd say that is true. It says single shear values for joints consisting of 2 wood members have a minimum thickness Not okay, but we don't have single shear. We have a double shear. That yes, this applies as a double shear situation, and we can check it. Sure, it does. And then we go down to 4. It says the length specified is the length of the bolt in the main member of double shear joints, or the length of the bolt in the thinner member of single shear joints. So it's in the main. Oh well, shoot. So we don't do. It says that the length specified is the length of the bolt in the main member of double shear joints. Oh, well, we have a double shear joint, so it's in the main member. So we use that 3.5 on the table. We don't go in and do this. We do not do that. We don't do a single shear instance for the 2, despite how much it might seem like you want to. But if you read the notes and always... Once again, if you just don't do this every day, how in the heck would you know to do that? So here is your answer, and it is A. Number 8 is A. And I hope that helped. And hopefully you didn't overthink this and just say, oh, it's double shear, you got it right off the bat. But once again, I probably, if I didn't know any better, I may have gotten that one wrong. But the good thing is, I would have been horribly conservative. I would have been probably around factor 2 conservative. Oh, more than factor 2. So, it'll hold up, and who cares? I just spend a little bit more money than I should have. But if you multiply that over the course of a huge structure, yeah, that could be a lot of money. Anyways, moving right along. Number 9, 2 angles, 3 by 3 times 3/8 of ASTM A36 steel are connected with a 1/4 inch fillet weld as shown below and using E60 electrodes. What is the allowable P? Alright, I guess I'll go ahead and sketch it. And I apologize for my haphazard sketch here. So this is an angle. I hope that this is like a plan view looking down. This is some sort of plate, I guess. Maybe it says that, I don't remember. But these are, this is a plate, and this is actually a double angle. So there's 2 of these angles right here. There's one on this side, and then there's one on the back side of that plate. So you're actually going to have 4 welds. Times, 3 inches each. And then you have, this is P coming out this way. They're saying, what is allowable P? And you have 2 3 by 3 by 3/8, and this is A36. Alright, so we want to figure out what the allowable P is. Sorry, I'm going to put P down here. Let's go back to purple. And so you need to do 2 things. You need to figure out what's the allowable of the double angles, and what is the allowable of the welds, and which one controls, and that is your controlling allowable P. So let's go ahead and do this. Let's start with the P's. And we know that this is a tension load. So assuming the weld's going to hold, so you can kind of say, oh, well, that's more or less a fixed. It could be pinned, but it's going to hold. Let's just say that. So you pull on it, you have a tension stress equals P over A. Alright, so we need to figure out A. And what we said. I've said in the past that you want to make this the max possible, and the max possible is your allowable. So you want to substitute in the allowable tension stress, and that equals 0.6. And I mentioned where this is. It's in the specifications part. I think, I don't remember what it is, part D, I'm guessing. Let me look real quick in the specifications index here. Yeah, it's a chapter D in your specifications. So look for the part where it says SPEC and then go to chapter D. And it says 0.6 of FY, which we know is 0.6 of 36 KSI. equals 0.6 times 36. I don't know off the top of my head. 21.6 KSI. All right, so equals 21.6 KSI equals P max over A. A we need to find, so we go to the beginning. Well, this is what I would do. It's probably in a few different places, but the easiest place is just to go to the beginning of your steelbook and look up angles. Angles, and you want to go to 3 3 3/8, 3 3 3/8. It's on page 1-49. 3 3 3/8, and we were looking for area, which is 2.11. So we want to say there's two of them. That shows 2 times 2.11 inches squared. Solve for P max, and we get P max equals 21.6 times 2 times 2.11. 91.2, let's round up. 91.2 kips. All right, so that is for the angles by themselves. Let's go ahead and change colors. That's denoting that, hey, I took a cross section there. Hopefully you understood that. If not, don't worry about it. And then we have 4 welds at 3/4 inch each. They are 1/4 inch fillet welds. So we're going to say, I'm just going to go fast here because I'm running out of time. Remember, it's the 0.707 times the distance of the weld, which is 1/4 inch. And then we want to multiply that times your allowable weld, which is what? I'm going to 0.3 times 60. We're going to say 60 for E60K electrodes. 0.3 is in the allowable for the, go to the specs and find that. We found in one of the other videos, so I'm not going to go over that again. And this is going to be per inch. So let's see what we're getting per inch. And then we multiply it by how many inches we have, which is what, 12. Times 0.3 times 60. And then you get 3.2, give or take. And that's going to be what? Kips per inch weld. And this is going to be 12 inches. So 12 inches times 3.2 kips per inch. Sorry if that's a little bit messy, hard to read. And you get 38.4. 38.4 kips. And as you can see, this is much larger than this, so this will control. Let's look at the answers, and we see that D is 38.16. I have rounded. It is close enough. D is your answer for number 9. All right, going on to number 10, the final. And it is asking us, at what angle of load to grain do wood fasteners have the greatest strength? And we know that it's parallel to grain. And that is A, 0 degrees. And that was extremely quick and simple. Thank you, Lordy, because I was running out of time. All right, and that is the end of the Lesson 7 quiz. Once again, if you have any questions or comments, please go ahead and just post them on this site, or if I have my website set up soon, you can post it on that, and hopefully I can address any questions you have. All right, I will see you in Lesson 8, Foundations.